Welcome back to Advent of Code 2017, day 10, not hash. You came across some programs that are trying to implement a software emulation of a hash based on not tying. The hash these programs are implementing isn't very strong, but you decide to help them anyway. You make a mental note to remind the elves later not to invent their own cryptographic functions. This hash function simulates tying a knot in a circle of string with 256 marks on it. Based on the input of the to be hashed, the function repeatedly selects the span of string, brings the ends together, and gives the span a half twist to reverse the order of the marks within it. After doing this many times, the order of the marks is used to build the resulting hash. So we have 1, 2, 3, 0, 1, 2, 3, 4, 5, pinch, 5, 0, 1. So we have twist X. What? Tying a knot in a circle of a string with 256 marks on it. To achieve to begin with a list of numbers from 0 to 255, a current position which begins at 0, the first element, and a skip size which starts at 0, and the sequence of lengths, your puzzle input. Then, for each length, reverse the order of that length of elements in the list, starting with the element at the current position, move the current position forward by that length, plus the skip size, increase the skip size by 1. The list is circular. The current position and length try to reverse elements beyond the end of the list. The operation reverses using as many extra elements as needed from the front of the list. The current position moves past the end of the list, it wraps around to the front. Lengths larger than the size of lists are invalid. Then there's an example. The first two numbers in the list end up being 3 and 4. Okay, so just keep track of all these positions. To check the process, you can multiply them together, produce 12. However, you should instead use standard list of size 256 with values 0 to 255 and the sequence of lengths in your puzzle input. Once this process is complete, what is the result of multiplying the first two numbers in the list? Okay, so we just have to implement this with a circular list. So we have to delete all this stuff. File path, read lines. No, this was just some notes. Let's see. Oops. Okay, so begin with the list of numbers. L equals this. Mutable list. Current position is 0. Skip size 0. Sequence of length or puzzle input. What does that look like? Okay. This is just this. Mm. Okay, we could just have to split like this, I think. And we have some input. So we have this is the where was the other instructions? Sequence of length. Length equals input. Then for each length, reverse the order of that length of elements in the list, starting with the element at the current position. So we want to make some kind of function, I think, list of int dot take starting point int and amount size. So we get start until start plus length is start plus length smaller than this dot last index. Just return that. Otherwise, I have to wrap around. So we have to build something. First part is this. Second part is this dot sublist 0 2 start plus length modulo this dot size. Then let's get this. It dot curve to length, which is this one. Then we want to reverse it. And you want to kind of insert it again, right? Move, okay, reverse the order of that length of elements. You're still in the first one. New reversed is this part. Then we want to insert candidate part. So we need another function. Replace from with kind of like part, partial, then similarly we can just check if this is, then we just get get the there's a list basically. In this case, we have this dot 0 to start. Then we go this is like the easy case. And then if start plus length, if it's overlapping, we have to do something similar, I think. Let's just take the result. Because we can kind of start with the end part. There must be some kind of middle part. That is my list. Starting from modulo this dot size. Just start until start. Then there's a first part. It's kind of like the end of, let's see how much this is. Range is sublist. Oh, you know, it would be easier maybe. I have two lists. First part and the second part. Maybe I even make a class. I just return a parted list here. This part just has an empty list. Because the second one is going to wrap around one. And then I have first part list. Second part list. I need to reverse as well. Let's just reverse it as well. Um, so first part and then second part. I reverse the values. And I want to take, oh, I can use take. take and drop. Return this. And I have this this thing. And if it's easy to just do it all in one move. Yes, also. Now we have two parts. I feel like we can just easily update it now. L dot replace. Then we do the same again. Cur length. Second part. Don't think we need length. And then we just, okay, let's just delete all of this. We want to while C smaller than index is start plus C modulo this dot size. That way I stay within 0 to last index. Then I offset based on the start. So now I can just go this, that IDX equals first part C. Okay, and then I have like get a mutable list, and then that's the one that I update. If C is smaller than I've always been using size now, so use size again. Else take from second part, turn result. Okay, I'm not increasing. See, that's wrong. That's good. Then we just update L. Wonder why can't we like we can just do this here. Here, and then we just update L there. Then something with okay, now we managed to do one instruction, which is reverse the order and start with the element at the current position. Move the current position forward by that length plus the skip size. Okay, we move forward by that length. What length? Ah, this length. Okay. Current plus equals length. Plus skip size. Skip size plus 1. Then L0 times L1. That exception. it could be my last index as well, though. +1? No, size was better than. What? This sublist start at 3 or 4. That's really high number. Oh, how does current get so big? Maybe L is getting bigger. Let's see what happens. L is size this, okay. Looks like AL is staying the same size. Why start 300? $91. What is 189, 111? Okay, 111. Start at 191. Ah, no, that's fine. We start here. Still working. Oh, not plus equals. Current plus blend plus skip size and then modulo. There we go. Try that. And we're off to part 2. The logic you've constructed forms a single round of not hash algorithm. Running the full thing requires many of these rounds. Some input and output processing is also required. First, from now on, your input should be taken not as a list of numbers, but as a string of bytes using their ASCII codes. This will allow you to handle arbitrary ASCII strings, and it also ensures that your input lengths are never larger than 255. For example, if you're given 1 to 3, you should convert it to ASCII codes for each character. 49, 44, 50, 44, 51. The commas as well. Once you have determined the sequence of lengths to use, add the following length to the end of the sequence. For example, if you're given this, then you add the length, the ASCII codes. Second, instead of merely running one round like you did before, run a total of 64 rounds using the same length sequence in each round. The current position and skip size should be preserved between rounds. For example, if the previous example was your first round, you would start your second round with the same length sequence. Now, assuming they came from ASCII codes and include the suffix, but start with the previous round's current position and skip size. Length sequence goes again, but then the positions retained. Once the rounds are complete, you will be left with the numbers from 0 to 255 in some order called sparse hash. Your next task is to reduce these to a list of only 16 numbers called dense hash. To do this, use numeric bitwise XOR to combine each consecutive block of 16 numbers in the sparse hash. There are 16 such blocks. So the first element in the dense hash is the first 16 elements of the sparse hash XOR together. The second element of the dense hash, the second 16, and so on. For example, if the first 16 elements of your sparse hash are as shown below, the XOR operator hat, you would calculate the first output number like this. Perform this operation on each of the 16 blocks of 16 dense numbers in your sparse hash to determine the 16 numbers in your dense hash. Finally, the standard way to represent a NOT hash is a single hexadecimal string. The final output is the dense hash in hexadecimal notation. Because each number in your dense hash will be between 0 and 255 inclusive, always represent each number as 2 hexadecimal digits, including a leading 0 as necessary. So if your first three numbers are 64, 7, 255, they correspond to the hexadecimal number as 40, 7, and FF. And so the first 6 characters of the hash would be that. Because every NOT hash is 16 such numbers, the hexadecimal representation is always 32 hexadecimal digits 0 to F long. Here are some example hashes: empty string, AOC, and so on. Treating your puzzle input as a string of ASCII characters. What is the NOT hash of your puzzle input? Ignore all leading or trailing Y space you might encounter. All right. Okay, so we need to run this few times. Mm. Run algorithm. I want to get the previous round current position skip size. So I need to input it and return it. Say we have algo config. I can add this 0, 0. I can return it. I can say equals this, and then I put in and I get it out. Okay. Return it in the end. So now I can run 64 times. This. So I can do this. Then I have to change the algorithm. Okay, what's the first thing? First, we get ASCII codes. How do I get those? And let's say code. Tooch. Um, $49. One's $49. The comma is 44. Okay, so I get the code. So maybe I want to run it once. On input. And then I can have input 2 is line dot code. And then that's what I run here. So I have the ASCII codes. Add those lengths. Second, instead of merely running one round, run a total of 64 rounds. Some order. I have to do a bitwise OR for each 16. I wonder if I should like return the list as well. Mm, hmm. I mean, I can also do this. Then we have actually we're interested in inputs 2. Do the X by XOR thing. Then we do a hexadecimal string. Okay, XOR is chunked 16 map. Okay, we have a list of chunk. This chunk, I wanna XOR. There's XOR. You have to like fold it or something. Fold. Fold. Dense hash. Dense hash needs to be hexadecimal string. Mm, And then for each map to hex string. Okay. Um, hmm, okay, then I need to trim. How do I get rid of the zeros? Or just always take the last two. Take last two. Okay, here we go. 64 times. Okay, that would have been too nice if it just works. Mm. So at the end, let's run this test. Okay, so it's not really correct. Have we not had just 16 numbers? Hexadecimal representation is always 32. Wonder if they start with the let's just do something like this maybe. One, two, three. Let's see what input 2 is. Okay. Input 2 is 49, 44, so on until 23. 49, 44, 50, 44, 51. Once you determine the sequence of lengths to use, add the following lengths to the end of the sequence. Here we have those 17, 31, 3. Okay, so we have this This looks good. Instead of merely running one round, run 64 rounds using the same length sequence in each round. Length sequence same. Okay. Am I doing that? Lengths are the input. Okay, cool. The current position in skips should be preserved. Previous example was your first round. Here's example. 3415 stays 3415 with the suffix. Has 4 at the end. Yeah. Once the rounds are complete, you will be left with the numbers from 0 to 555 in some order. Numeric bitwise to combine the consecutive block of 16 numbers in sparse. There are 16 such blocks. Okay. See if this is correct. That part seems to work fine. 40. That works. Yeah, it's always the last two. Oh, I know, I'm taking the last two. Hmm. Yeah, so 1, 2, 3 should be 3e and so on. But it's something else, and I don't really know how to find out what's wrong. We run it 64 times. We update the algo config input. Got this. I should check that one. 3fe, 3ef. Oh, L. So input of the lens. L is updated. I return. So I shouldn't. Pass it in. Okay, let's go. Input is something else. Input is 0 to input 2 is length to length 2. Output is input 2. Oops. Yeah. There's input 2 here and put length 2 in. Lengths are always the same. Input changes. Output, input. Okay, let's do this. Don't know what happened now. Input 2 is this. Oh, maybe it reflected something in a weird way. Oh, that's fine. Input 2 chunked. And that's it. No, we take the input, use the same length sequence, update the current position. Hmm. 32. Let's check the output of this. What else can I be doing wrong here? I think XORing will work fine. We can check it again. Mm, Skip size always goes up 10, which means there's 10 lengths. Why is there only 10 lengths? Oh, yeah. Now it will go further. Skip size is 56. 100. How many lengths? I don't know. 56. Skip size 560. That's fine if it's super high. It will still work. Thing to try is this, because I need a list of length. And when I go start to start plus length, and I had +1 and I get one too many. Do the quick test here. I go from 0 to 3, the size is 3, which is what I want. If I go 0, 3 plus 1, size is 4. So let's run everything again. And yeah, check this. And that's it. Okay, so there was just a tiny bug in one of the sublists. Let's go through the solutions of a part 1. We take the input, these are the lengths, and then we just map them to int, these ones. Then we get our input, which is a list from 0 to 255, and it's a circular list. So we can run our algorithm with this input, get the list mutable in L. Current is 0 at the beginning, and skip size is 0. And then for each of the lengths, we go split the list into first and second part. And what we do is we take and reverse. So we take the first part. If we, based on our starting index plus length, are larger than last index in this list, then we need to wrap around. So basically that means first part has something and second part has something. And a simpler case, if this is smaller or equal to last index, we just take a sublist from start to start plus length. Second part is empty, then we can just reverse it. And then we take from this reversed list the first part dot size and second part, and drop the first part of size for the second part. So it's just empty here. And then we can return that. For the more advanced case, when we wrap around, we take a first part, which is from start to the end. So this dot last index plus 1. Then we, for the rest of the length, which is start plus length modulo this dot size. So everything that hangs over the end of the edge of the list, we go take from the start, so sublist 0 until then. Then we patch them together, reverse them. So it's one chunk that we reverse all the elements in it. And then we take the first part size from this reversed list and say this is the reversed first part, and then the rest of it, which is drop, is a reversed second part. What we have then is two parts, the end of the list and the start of the list, with all the elements in the reversed order already. And then we just have to add them in. So L, which is our mutable version of our list, add an index, I add in either from first part or from second part, depending on where I'm in the list. So the index is current, which is the offset, plus C, which starts at 0 and counts up, modulo L dot size. So we start adding one by one in from the first part until that's all of those are added in. And then we add from the second part, which will be at the beginning of the list. Then we just do that incrementally, update cur and skip size like the instructions said, and then part one is this first element of the list times the second element of the list. Then we return the algorithm output, which is the config, which is the current size and the skip size at the current state, and the updated list. And then we have the first part of the puzzle. Second part, we map the lengths differently. Initially we mapped with int, now we map with code. Then, which is, the code is the char code, the ASCII code. Then we add these 5 numbers at the end. We take the same input, which is 0 to 255 as a list. We also have a 00 algo config, and then we run our algorithm 64 times this time. So we repeat 64 times. And we input our input for part 2, our length for part 2, and our algo config. Then we do the same thing with this new type of list, which has like more lengths because every character is a number. We always return cur, which current index we're pointing to, and skip size back in our algo output, as well as the updated list, which is originally was input. So we have our output. Then we can update the list, which originally was 0 to 255 to be input 2, and the algo config to be the algo config from the previous run. And that's what we do for 65 times. Then we apply, based on this output, which is this stored in the input here, input 2, we want to always take 16 values from that list. So each chunk has 16. We can check as well. Each chunk has 16 elements. And then what we want to do is XOR them one after the other. So we start with the first one. So we remove the first one from the list, fold by starting with the initial value of the first one. What folding does is it always takes 2 values, initially this one, and then one by one all the other elements in the list, and XOR X and Y, which is this current one and the next one. That's what we map here. So then we have a list with 16 integers, which we then turn to a hex string where we take the last two the last two characters of this string, because we know we're between 0 and 255, so we know that everything's 0, 0, 0, 0, and then the last two values are valid or important for us. And then our length will be 32, and our output is the joined hex string. And that's what we need for part 2. That's it. Enjoy the rest of your day.